Welcome everyone. Today we are going to discuss about the visualization of Laplace transform. In previous video we learned about how the time domain converted into the complex domain. It is nothing but the Laplace transform. Okay, so now in this session we plot a graph between the time domain to the Laplace domain. That means complex domain. Okay, now let's enter to the MATLAB code. So the MATLAB is a software used to analyze the signals, particularly in Laplace transform, Z transform, and control system and frequency analysis. Okay, so I'm using the Laplace transform in mathematical code to run the code to the MATLAB. Okay, so now I am assuming the code sims t and s because I am using t variable and s variable. T variable is nothing but time domain and s variable is nothing but complex domain. I assume a is nothing but amplitude. A is equal to 1 is nothing but amplitude of the complex domain or frequency domain or time domain. For it is only based on the assumption. Now I put on a frequency value, the limit up to 440. For example, I need whatever you want, you can put it also. Okay, so now the signal. So the signal function is, I write it like that, signal of f of t is equal to signal f of t is equal to a multiplied by sine. I using the sine function. That's it. Sine of, for example, I put 2 pi. Okay, so 2 into pi. Okay, 2 into pi into t, and also I multiplied by some functions. Whatever you can put it, I put it on exponential function. Okay, so so exponential of minus t or plus t. Okay, I put it minus t. Okay, okay. So then now the time domain signal are produced. Now this time domain signal is converted into the S domain signal is nothing but complex signal. Okay, so in MATLAB we can easily convert a time domain signal to S domain signal by using the inbuilt function, that is nothing but Laplace. Okay, so signal S is nothing but complex signal is multiplied by, so Laplace using the inbuilt function Laplace. Okay, using the inbuilt function Laplace function, first let's write as a function signal space bar t, it's already mentioned, comma, frequency up to 440 level, comma, then time. Okay, okay, then converted into yes domain. It's simple. Okay, now display the signal. Yes, that's it. So now I run this code. Oh, it's come wrong. Oh wait, oh, this is error. So I put it wrong in variable. So signal t, it's function of t, it's converted to x. That's it. So I run this code. Yeah, now it's coming. So I am given function is 2 pi divided by s plus 1 plus 4 pi square. So the see, this place is a signal of t is equal to e power minus t into sine 2 pi t. It is the given signal. Now converted the time domain signal converted into the Laplace 2 pi divided by s plus 1 whole square plus 4 pi square. So using inbuilt function we can directly convert it to the time domain to complex domain. It is very much easier for converting. Now plot the graph between the time domain and the complex domain. How the graph look like that, we'll see now. So let's plot the graph. First plot the time domain signal. So first, this is the f of t. So it have some value. It has a general function. I put some value to plot a graph. Randomly, I put some value. For example, t is equal to 1, t is equal to 2, t is equal to 3. So f of when I put t value, some f of t will get. So using the t and f of t, I draw a plot. Okay. Okay. So I put a random value, fs gives 1000. Okay. Okay. So t vals. So now I using one inbuilt function. The t val is equal to. So the link space. So it is a MATLAB inbuilt function to take random values between the two endpoints. I take 0 to 0.01 to 1000. Okay. Okay. So in between 0 to 1000, that some take random points. Okay. Okay. So the time signal will plot like that. Time signal is equal to, now call upon the function. So this is a function, you know. Okay, I copied it and paste it again. So instead of t, I put t vals because now I take the random values. Okay, so similar displays also. So t vals. Okay, is it okay? Okay, okay. So figure subplot. Okay, subplot. Oh, okay, subplot 2 comma 1 comma 1. Okay, then plot between t vals because new values versus with respect to time signal. Okay, time signal. Okay, then denoted as a b dash. Oh, okay, blue indicates a color of the curve. Okay, so I put a title. Okay, I put a title like it is a time domain. So I forgot to put a apostrophe colon. Okay, then x label is nothing but your time. Similarly, I write it down a y label. It's nothing but amplitude with respective value of the f of t. Okay, okay. So now I put a function grid on. So grid on means when the complex function generated, that means the complex value generated, after that the time value will appear. That means we'll plot both the plot in same time. That is the reason only you using the grid on. Okay. So now frequency domain. Okay. So frequency domain, I use a new function omega. Similarly, take linspace 0 to some thousands, whatever value we want, you take it as. For a 0, in previous case we take 0.1, in this case I take 1000. Okay, no problem. Then yes vals. Similarly, I put some values 1i, because it is a complex function, is plus 1i into omega. Okay, okay. Then frequency response is equal to double subplot, double subplot. That means plot plot the time and frequency domain together. Signal, signal. Yes, we already have. Now yes vals. Okay, okay. So now again subplot. Now call upon the functions subplot 2 comma 1 comma and 2. So plot frequency graph omega comma absolute. Absolute means it indicates only a integer values or whole values. Frequency response and denoted as a red. The red indicates a color, or in previous we use B, that indicates a blue color. In this case we use a red. Similarly title. So complex domain. Okay, complex domain, X label and Y label also. X label is frequency. So Y label, sorry, it's amplitude. Now grid on. That means closing the function. Now, okay. So now run this code. It shows some error. Wait, oh, I, okay, oh, okay. So the time domain graph will shows the error was corrected. Now see. So this is a t value the randomly took the computer, and this is a time domain. Okay, and in bottom we have a complex domain. This function in the blue color indicates a time domain function. It's converted into the complex domain function. Okay, it is clear. So it is a visualization of the time domain to the complex domain. How the Laplace transform converted into the time domain to Laplace domain. Okay, okay.